10-2 is all about square roots and reducing square roots. Mathematically, we can call a square root a radical. So a radical expression is an expression that contains a radical. The other way you could look at that is, in this chapter at least, a radical, when we refer to a radical, we're talking about square roots. There are other types of roots that can be called radicals, but for this chapter, we're talking about square roots. So to simplify radicals, we do need to know our perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Remember that what that exponent is saying, that exponent is telling us that 3 squared is written out as 3 times 3, which equals 9. And then we have 4 squared, because 4 times 4 gives us 16. And 5 squared is 25. And you can keep going. 6 squared is 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared is 100. So we do have a property, a multiplication property of square roots. So for where A is greater than or equal to 0 and B is greater than or equal to 0, if we have the square root of A and the square root of B, because they're both underneath square roots, we can multiply them underneath square roots. It's important to know that we can take separate square roots and multiply them and put them underneath the same square root, or we could go in the reverse. We could break it apart. We could take a square root where two numbers are being multiplied and separate them out. So an example of this, though, is where we do have square root of 48. We can change that to the square root of 16 times 3, and then we can separate it out. So we took a product and we separated it and put it underneath two different square roots. And then one of those most likely is going to be a perfect square, which we can simplify down. The square root of 16 is 4. And then the square root of 3 just gets left underneath there. So we're going to try one of these examples. So what is the simplified form of the square root of 8? So first we need to find the greatest perfect square from the table above that divides into 8 evenly. So again, think of the numbers that divide into 8. You could think of 1 and 8, because 1 times 8 gives us 8. 4 and 2, right? Just think of factors, and then you want to narrow that down and think of the greatest perfect square that divides into 8 evenly. So 4 is a perfect square. 1 and 8 are not. Well, 8 is not. 4 is a perfect square, and that is the biggest one that divides into 8 evenly. So we can write that on the blank, 4. Then rewrite the number under the radical as a product. So we have the square root of 4, and the 4 times what gives us 8? 4 times 2. So we just broke 8 down into 4 times 2. Then we're going to break up the square root so that now we have two radical expressions, so that it's the square root of 4 times 2. Now simplify the perfect square radical. So this is important too. This square root of 2, it cannot be simplified. If you type in square root of 2 into your calculator, you're going to get an irrational number. It's never going to end, and it's never going to repeat. The square root of 4, however, the square root of 4 is equal to 2. So this square root of 4, it's equal to 2, and we lose the square root sign. We only keep the square root sign for the numbers that can't be simplified. So now we're going to go over another type of example, which is, let's say we had separate square root signs. We're going to multiply these two together. So if we have 4 square root of 3 times 2 square root of 6, we're going to multiply the numbers on the outside of the radical first. So we're going to take this 4 and multiply it by 2. 4 times 2 gives us 8. And now we still have square root of 3 times the square root of 6. So just like before, only in reverse, we're now going to write this as 1 square root, so that it's 3 times 6 underneath 1 square root sign. And now we can multiply them. 3 times 6 is 18. 8 square roots of 18. 18 is not in simplest form because there is a square root, a perfect square that divides into 18. If we think of the factors of 18, we could break it down. 18 has factors of 9 times 2. So 9, being that it is a perfect square, we have to keep simplifying this square root. So we have 8 times the square root of 9 times the square root of 2. Again, we broke up a product and put it into 2 different square root signs. And then you have to think about which one of these simplifies down further. Square root of 2 does not simplify further, but square root of 9, if we were to type that into our calculators, or if we were to think backwards, so that we thought of what number times itself twice gives us 9, we would get 3. So then we can simplify this further. 8 times 3 is 24 square roots of 2. That's a challenging one because a lot of times people leave it here and they forget that they have to simplify it further. Our final answer is here. So we just have to remember to look at that number underneath the square root and see if there's any type of perfect square that divides into it. And now you can practice some of these on your own.